Good afternoon, everybody. May I have your attention, please? Yeah, good afternoon, everybody here in the room. Good afternoon, everybody, or good day, everybody online. My name is Matthew Herniger. I am a senior scientist here at OKU. I deal with hydrology and catchment modeling. And it's a pleasure to host or share this session today on climate change. And yeah, we expect to have better presentations dealing with different topics related to climate change. And the format is such that we will have videos presenting the posters of about 3 minutes, and then we will have a chance to ask questions. Please, we start off with the first poster with the topic, or with called Biosphere Learning Laboratory Lake Bossomtwe, the Biosphere Reservoir Management in Times of Climate Change.
Ladies and gentlemen, warm welcome.
Outside or in the program, it says here in the online program.
Okay. So sorry, what is food and nutrition technology?
E101 is in the first floor.
So we should go there now.
Yeah, you're interested.
Thank you.
Sorry, I didn't have the program. I just
Okay, fine.
Ladies and gentlemen, warm welcome. My name is Tobias Kremer. I'm working at Eberswalde University for Sustainable Development in Germany, and I want to give you some insights on our Biosphere Learning Laboratory, Lake Bossomtwe in Ghana. The UNESCO Biosphere Reserve, Lake Bossomtwe, is located close to the second largest city of Ghana, Kumasi, in the Ashanti region, and as so many biosphere reserves, it's facing severe challenges like the overexploitation of the fish and the forest resources that will further increase this overexploitation in the future, but also a not existing visitor management, so too many tourists that are not controllable, and we did see that the local and the regional population is hardly aware of the status of the region as a biosphere reserve. So the acceptance of the biosphere reserve as a model region for sustainable development is rather poor. What did we therefore do together with our Ghanaian university partners and the Forest Research Institute of Ghana. We did an in-depth analysis of the needs and demands for research and transfer in the biosphere reserve to foster sustainable development. So together with the local population and many other stakeholders, we were developing a research outline with 7 priority research and transfer areas, such as agriculture, forestry, or fisheries. And we were then in the next step tackling these research areas with in-field, very practical work on ground by exchanging students, 8 students traveling to Ghana for 8 to 12 weeks, and together with the Ghanaian partners doing research on exactly these topics. What did we in the end learn, or what did we achieve? We were establishing a strong professional network of researchers. We were promoting relevant practice-oriented teaching and research methods. We were developing the research outline I was just showing, and we were able to provide first results and approaches for follow-up research projects and transfer activities. One of them just started on NTFP domestication and cocoa systems diversification at Lake Bosomtwe Biosphere Reserve. Finally, what did we learn? Next time we would like to achieve a stronger involvement of the indirect partners through Ghanaian partner universities. We would also like to more strongly directly involve the Biosphere Reserve's management, and we would like to see a more formal exchange between students from the universities in both directions. Thanks much for your attention.
Thank you very much, Professor Kremer. Is he online? We see the participants. Okay, he's unfortunately not online, so I hope there are no questions. So I think we can continue with the second presentation on crop management practices and coping strategies of rice farmers in typhoon-prone Eastern Visayas, Philippines.
To all participants, organizers, and guests, good afternoon. Good evening from the Philippines. I want to share with you some of the results of our research, crop management practices, and coping strategies of rice farmers in typhoon-prone Eastern Visayas, Philippines. In recent years, typhoon occurrences in the Philippines have surged from 15 to 20 annually, particularly impacting the Eastern Visayas Islands in the central Philippines. These typhoons have heavily affected the crop management practices of farmers in the region. Hence, this study aimed to look at how farmers cope with the impacts of these typhoons. Using interview guide questions, data were synthesized and analyzed using Excel to identify common themes. 40 lowland rice farmers in 3 farming communities of Eastern Visayas were interviewed to assess the impact of climate-induced typhoons on crop management practices and identify farmers' coping mechanisms in these heavily typhoon-affected regions. Table 1 shows the effects of climate-related stresses on rice farming and coping strategies. It shows that farmers practice emotion-focused and problem-focused coping strategies. Emotion-focused is when farmers are passive and have resigned themselves to not doing anything about their problems. One example is waiting for the rain to come, which is a passive coping strategy that instead of addressing the scarcity of water, they passively wait for natural conditions like rainfall to occur. Emotion-focused coping strategies are maladaptive actions. Another example is leaving the land idle or planting once or no planting at all is a form of avoidance as shown in Figure 3 that does not directly address managing crops under limited water conditions. This strategy involves taking initial action, like planting, and then waiting, which could be seen as addressing the problem to some extent. However, idleness suggests a passive approach, and managing the situation through inaction until conditions improve is a form of emotion-focused coping strategy aimed at reducing the distress associated with constant active management without immediate results. Choosing not to plant is a form of frustration related to dealing with insufficient water. Results also show that farmers practice problem-focused strategies as shown in Figure 5, which involve direct actions aimed at resolving specific issues like water management or crop resilience. One example is switching to other crops such as sweet potato that are more resilient or suited to the current conditions, which directly addresses the challenge. In conclusion, farmers are more prone to maladaptive strategies because they lack access to government support services and support from fellow farmers. Support is very important for coping, and this does not exist in the area. Philippine government should focus on a long-term governance approaches to help the community of farmers in Eastern Visayas. Thank you.
So thank you very much for this interesting presentation. Are there any questions from the audience online? Okay, then I think we can proceed with the next presentation.
Hello everybody, this is Hossein Mostafavi from Shahid Beheshti University of Tehran. Hello everybody, this is Hossein Mostafavi from Shahid Beheshti University of Tehran, Iran. Today I am very happy to talk about a very important topic that I know everyone knows. This is a very important issue in the world. Our study was about the modeling of the climate change impacts on the Iranian river and fish species diversity as a hotspot area in the world. And objectives were to estimate climate change impacts on the fish species distribution and diversity, as well as to estimate climate change impacts on the alterations in fish species distribution patterns. Our study area was international scale, including 19 basins, and we have selected 131 river and fish species, and for modeling we have selected and identified non-environmental variables, and in order to remove the collinearity we have used the Spearman correlation test. Species distribution modeling, we have applied Maxent algorithm in our program and the DISMO package, and we have used tenfold classification as well as IUC criteria for the assessment of the modeling accuracy and performance, and we also use the optimistic and pessimistic RCP in different years in order to project the climate change impacts. And finally, we have calculated the range shift according to the following table. According to our result, the IUC values for all models were valid, and the species have been reacted differently in the advent of future climate change. In addition, most species showed both reduction and expansion. Moreover, the impacts of the climate change impacts on the endemic, non-native, and native fish species, as well as IUCN Red List species and other species have been shown in the different charts, and you can see them in this slide. And finally, the Southern Caspian Sea Basin, as well as Western Zagros and Northwestern of Iran, face the highest future species reduction. In conclusion, climate change severely impacts the fish species diversity and distribution of Iran, and it is crucial to reduce the human pressures from land use, river fragmentation, and impaired hydromorphology and water quality. And it is necessary to be considered a number of strategies like stakeholder education, designing of the protected rivers, barrier removals, and riparian shading. Thank you very much for your attention. I would be very happy if you have any question to communicate with me. Have a nice evening.
Thank you very much for this presentation. I can see that Hussein Mustafafi is online, so please, if there are any questions from anybody online, please raise your hand. Okay, I can see that there is no question, everything is clear. So I think we can continue with the...
Hi everybody, my name is Jenny Ruiz and we have conducted research titled Hi everybody, my name is Jenny Ruiz and we have conducted research titled Greenhouse Gases in Livestock Farming, the case study in Flevi cattle in the Peruvian Amazon. Our research was conducted in the Amazon region with surveys carried out in 4 provinces, Chachapoyas, Ley System 1, Bongará, Ley System 2, Rodriguez de Mendoza, Ley System 3, and Utcubamba, Ley System 4. This region is located between the Andes Mountains and the Amazon in the northeastern of Peru. In this region, small-scale dairy and beef production is essential for the economy and food security, but reducing its environmental impact requires sustainable practices. The carbon footprint, which is used to calculate greenhouse gas emissions through the life cycle of a product, is key to this purpose. Therefore, our objective was to estimate the carbon footprint of Flevi cattle production systems in the Peruvian Amazon region. As a methodology, the guidelines of the Intergovernmental Panel on Climate Change from 2018 were used. Also, the system boundaries on Flevi cattle farms were using a cradle-to-farm gate approach, as we can see in Figure 1. A comparison between systems was done using Duncan statistical test. Additionally, correlation analysis was performed using Pearson correlation in SPSS software. System 1 exhibited lowest enteric emissions than System 2 and 4, with 67.7 kilograms of enteric methane per animal per year, as we can appreciate in Table 1. In Figure 2, we can observe that enteric methane represented 90.8% of total emissions, followed by nitrous oxide from manure management with 6.9%. In Table 2, we can show positive correlations between methane emissions with total fat protein corrected milk, animal units like dairy cows, and low-producing animals, which are all categories except lactating cows. As a conclusion, our study highlights the need to optimize herd composition, increase production levels, and decrease low-productive animals, steers, male and female calves, dry cows, to reduce the carbon footprint. Improving the forage nutritive value can increase milk production, securing the economic well-being of smallholder farmers and the sustainability of the farming sector in the Peruvian Amazon. Thank you very much for your attention.
So thank you very much for this nice presentation. Are there any questions from the audience? If not, I would suggest that we continue with the next presentation, and it's about identification of potential future areas of sustainable.
Thank you so much.
production in Togo using the Maxent model.
Thank you so much. I'm in front of you to talk about a topic entitled Identification of Potential Future Area for Sustainable Cashew Production in Togo using the Maxent model. This study will help us to identify the areas that are highly favorable for cashew production in Togo currently and predict the impact of climate change on those areas by the horizon 2015. By doing this, we combine environmental data and climatic data. There is a total of 17 environmental data, and we use occurrence data out of like 2,538 occurrence species, especially for Anacardium accidentalis cashew. And we use the hard gems and mirror model to predict this the future for our future projection and the shared social economic pathway. They took both at horizon 2015. As a result, we realized that the high contributor is the soil, which we can saw here, whereas the less contributor to the effectiveness of the model is the elevation, which we can saw here. What we can have as at a landscape level, we realize that currently 89.14% of Togo territory are highly favorable for cashew production. Of course, what will happen in 2050 if we are cultivating cashew in the way we are doing it? What will happen is that the current favorable area will be drastically reduced to more than 50%. So there is a need for us to act on that. That's why in the conclusion, I want to make a statement that we have to practice sustainable cashew production way, because at the year of 2015, we realized that more than 50% of those areas that are currently highly favorable for cashew production will be reduced. Therefore, there is a need for adaptation strategy, cultivation adaptation strategy in Togo in order to prevent those impacts on the area that are favorable for cashew production. Thank you so much.
Thank you very much for this presentation. I suggest that we proceed immediately due to time. And the next presentation will be on fertilizer management effect on rice growth and methane emissions in lowland paddy rice in Madagascar.
Dear auditors, I'm Lala. Dear auditors, I'm Lalaina Janartson, and I'm in my second year of PhD in the Doctoral School of Agriculture, Livestock and Environment at the University of Antananarivo in Madagascar. What I want to present to you today is about the manure and mineral fertilizer management effect on rice growth and methane emissions in nutrient-deficient lowlands of Madagascar's highland. Where in Madagascar, rice is a staple food for Malagasy people, and Madagascar has 115 kg consumption per capita, one of the highest consumption per capita rate in Africa. Due to low soil fertility and also access to fertilizer for farmers is difficult, rice production is insufficient to meet all populations' needs. Then, to improve rice productivity to ensure food security in Madagascar, application of fertilizer is important. However, it may increase methane emissions. So, our study aims to determine the effect of mineral and organic fertilizer on rice productivity and methane emissions. To achieve this goal, we conducted a pod and field experiment. In both experiments, we tested free treatments as control where no treatment was applied, mineral fertilizer using NPK, and organic fertilizer using farmyard manure. In field experiment, we tested NPK and farmyard manure. As a result, in both experiment, application of fertilizer increased significantly rice productivity and total methane emissions compared to control, and we obtained the higher rice yield in NPK and the higher straw yield in NPK compared to farmyard manure, but the lower total methane emission under NPK treatment was observed. In consequence, NPK fertilizer showed the lowest emission intensity. This parameter is important as it can determine the efficiency of one practice management. That's why we can say that NPK fertilizer could be a resilient practice to enhance rice productivity while mitigating methane emissions. In field experiment, there was no significant difference between NPK and farmyard manure treatments, even in rice yield or in total methane emissions. However, NPK showed an increasing trend in straw and grain yield and a decreasing trend on methane emissions compared to FIM or farmyard manure. Then NPK resulted the lowest emission intensity compared to farmyard manure. It allowed us to conclude that an effective management of NPK fertilizer will be important in order to ensure food security while mitigating methane emissions from lowland soil in Madagascar. That's all about my presentation. Thank you for your attention, and I'm here to answer your question. Thank you.
Thank you very much for this interesting presentation. Are there any questions from the audience? I do not see any, so I suggest we continue and move on to Uganda. Our next presentation is on adaptation of crop portfolios to perceived indicators of climate variability by smallholder farmers in southwestern Uganda.
The session chairperson. The session chairperson and participants, greetings from Uganda. My name is Dina, a doctoral student at Free University of Brussels and Imbara University of Science and Technology in Uganda. This presentation highlights adaptation of crop portfolios to perceived indicators of climate variability by smallholder farmers in southwestern Uganda. Crop portfolios simply refer to crop options, single or mixed, that farmers allocate land to, and climate variability, in simple terms, refers to fluctuations in the mean of climatic parameters, usually on a short time scale. In Uganda, rain-fed agriculture is the major source of livelihood for smallholder farmers, and these usually cultivate on less than 1 hectare of land. This form of agriculture is vulnerable to unpredictable variability in climate, which is a current global challenge. It is important to understand farmers' experience with climate variability and how their experience is integrated in crop production systems. This helps to inform farm-level adaptation. The aim of this study was to establish the linkage between how farmers perceive climate variability and crop selection. The study was carried out in 3 districts in southwestern Uganda. These are located in 3 agroecological zones. The approach was mainly through household survey. A pre-tested and digitized questionnaire was administered by trained enumerators to respondents that were selected through random sampling procedures. Key informant interviews supplemented data collection. The results indicate that in the first season, that runs from March through April to May, there was more negative perception of climate variability especially in terms of rainfall cessation and consistency. Season B, that runs from September, October, November, was characterized by more positive perceptions. In terms of crop production, 36 crops were recorded, and portfolios were dominated by annual crops. Legumes, cereals, and tubers were the major crop classes. There was higher diversification in season A. 60% of the farmers had a climate-related reason for crop selection, and this was dominated by drought and excessive rains. This study concludes that negative perception of rainfall cessation and consistency in season A could be driving higher diversification of annual crops in the respective season as a strategy to adapt to droughts. Thank you.
Thank you very much for this presentation, for this nice presentation. We have had questions in the chat. So Luz Asio asked about how the improvement in soil biological properties due to FIM application is present for the case study in Madagascar. And the answer is that the focus of the study was on greenhouse gas emissions, and that the study did not focus so much on the soil biological properties, but that they think there was an improvement of soil biological property, as there was also an increase in crop yield. Good, thank you very much. So I think we can continue. The next presentation has the title Water-Saving Irrigated Rice Cultivation Promotes Rice Plant Growth and Improves Farmers' Income.
Good afternoon, everyone. Good afternoon, everyone. My name is Duy Hoàng Vũ from Vietnam National University of Agriculture. Irrigated rice play an important role in food security. However, conventional rice cultivation usually maintains a ponded water layer throughout the growing season, resulting in high water consumption and a large amount of methane gas emission. Water-saving irrigation technology such as alternate wetting and drying, we call it AWD, has been developed and introduced in various rice growing regions. Previous studies have shown the benefits of AWD, but the implementation of the technology in practice is still limited. The project was carried out on a large area and in different regions of Vietnam. The aim was to evaluate the benefits of AWD in practice for farmers and thus motivate them to apply the technology. Our results show that, in addition to saving water, AWD also increased rice plant growth, including the number of thinner leaf area index, plant biomass, and resistance to lodging, resulting in higher grain yield compared to continuous flooding. This is particularly beneficial in the tropics, whereas often affected by monsoon and typhoon at harvest time. In addition, the application of AWD also promoted earthworm activity in the soil, which is of great importance for soil health and increase the oxygen content in the soil. Compared to continuous flooding, AWD also reduced disease infestation in rice, resulting in less use of pesticides. AWD significantly reduced methane gas emission in rice field, which was higher in transplanted rice than in direct seeded rice. Methane gas emission was reduced by improving the oxygen content in the soil, especially during the drying phase. A reduction in methane gas emission can be converted into carbon credit, which increase the income of rice farmers. Therefore, organizing the production and management of AWD system is an effective solution to adapt to climate change, reduce greenhouse gas emission, and improve farmer income, which motivates them to actively apply this technology in practice. Thank you.
So thank you very much for this presentation. We can continue with the next presentation on forecasting grain maize yield in sub-Saharan Africa, a hybrid modeling approach.
Hello. Hello everyone, today I'm going to present our poster about forecasting grain maize yield in sub-Saharan Africa using a hybrid modeling approach. As we know, we are facing dual challenges of climate change and ever-increasing global population, projected to surpass 9 billion by the year 2030. Which of course present unprecedented hurdles for the agricultural sector. These challenges underscore the need for developing precise and timely crop yield forecast. So to enhance these crop yield forecast models, various approaches have been explored in order to reduce uncertainties in model structure, input data, model parameters, exceeding observed yield variations over time and space. So in the present study, therefore, we tested the hybrid modeling approach, where the LSTM was used to tackle temporal variables and dense layer for the static variables to improve the accuracy of maize yield predictions compared to gradient boosting algorithms and light GBM across 39 sub-Saharan African countries. We did utilize some data. For instance, climate data was taken from ERA5 daily aggregated values from ECMWF climate reanalysis. As a variable, we used maximum and minimum air temperature, solar radiation, and precipitation. Soil data we utilized from soil grids available at 250 meter resolution. We used soil texture properties, organic carbon, and total nitrogen. We also utilized remote sensing data such as LAI and NDVI. And we also utilized net primary production data available from WAPOR, available at decadal level. We also took crop yield statistics at national scale from FAO databases. And it's worth mentioning here that we utilized all climate variables in LAI, aggregated into 10 days time period, while NDVI data that has been extracted was at 16-day interval. Now, for disaggregation purposes of the FAO yields, we followed certain steps, which you can see here in step 1, NPP values for the entire crop duration over crop lengths across sub-Saharan Africa were extracted at decadal intervals, and the mean NPP was calculated for each pixel. In the next step, the country-level average NPP were calculated by averaging NPP across all the pixel and time steps, followed by the step 3, where we calculated NPP ratio by dividing the average NPP for each pixel by the country-level average NPP. Then we disaggregated the FAO yield by multiplying this NPP ratio, and which brings us to the disaggregated FAO yield based on the NPP ratio for entire cropland. Now in this section, we see results where you can see on the top panel is the performance of XGBoost model in terms of actual and predicted yield. ABC denotes your training, testing, and validation data. The middle row is the light GPM model, and the bottom row is the DNN model performance. While on the right panel, you see Shapley feature importance for light GPM and XGBoost, which indicates that crop duration was the most important feature for the prediction of maize yield and its variability. While the bar chart compares also the performance of XGBoost, light GPM, and DNN across training, testing, and validation data using three evaluation metrics: R square, which is coefficient of determination, root mean square error, and mean absolute error. We can see that DNN performs best in the training and testing phases with higher R square and lower RMSE, suggesting that it fits well and generalizes across training and test data. However, XGBoost has the best performance in the validation phase with the lowest RMSE and MAE, which could mean it's less overfitted compared to DNN, while light GPM shows competitive results but slightly lags behind XGBoost mix, and especially in validation. So therefore, we conclude here that for overall model performance, DNN is superior for training and testing, but XGBoost shines in validation, which is of course more critical for the real world prediction accuracy. Thank you so much.
Thank you very much. We can continue with our next presentation, Impact of Climate Change on Oceanic Ecosystems, Challenges, Adaptations, and Strategies.
Good evening, and thank you for joining. Good evening, and thank you for joining my presentation. I'm Karolina Łachmacka from Wrocław's University of Environmental and Life Sciences, and today I'll be presenting my research on impact of climate change on oceanic ecosystems, challenges, adaptations, and strategies. This poster examines the impact of climate change on ocean ecosystems using secondary data and a literature review. Climate change is one of the greatest challenges of our time, with profound impact of ocean ecosystems, the foundation of life on Earth. We can notice warming waters and species migrations, disruption of weather patterns, ocean acidification, and melting ice and rising sea levels. In response to climate challenges, the ocean has developed certain adaptations, for example, marine organism adaptation, increased phytoplankton production, migrations of fish and other species, and evolution of new survival strategies. How do we support the ocean in this unequal battle? There are several strategies. Among the most important are marine protected areas, which are zones created to protect ecosystems by restricting harmful activities, reducing greenhouse gas emissions through international agreements, enforcing fishing limits and protecting fish habitats, and coastal restoration projects. At the same time, these climate changes disrupt ocean-based industries. From 1995 to 2020, shipbuilding, making marine equipment, and related service grew a lot. The GVA index went up to 2.5, which means it was more than 2.5 times higher than in 1995. The biggest growth was in offshore wind, marine renewables, and research, where the GVA index was almost 3 times higher. On the other hand, from data based on OECD scenario, between 2010 and 2030, the offshore oil and gas sector's share fell from 34% to 21%, and offshore wind energy dropped from 34% to 8%. At the same time, sectors like fish processing and port activities increased their shares from 5% to 9% and from 13% to 16%. Rising ocean temperatures and sea levels disrupt marine ecosystems in coastal areas. Solutions include expanding protected zones, reducing CO2 emissions, and restoring habitats. Marine species adapt by tolerating acidity, increasing phytoplankton growth, migrating, and evolving new strategies. Climate change has reduced offshore oil and wind energy while boosting fish processing and port activities.
Thank you very much. I would suggest we proceed to the last presentation, And the topic is, how does social capital promote adaptive behavior among Iranian farmers?
University. My research interest was on conservation, social science, and human decision-making behavior, category of farmers and producer environmental behavior. Today I'm excited to share my research on adaptation with climate change, actually how social capital helps farmers to climate change, to adapt to the climate change. This research undertaken in the center of Iran, as probably most of you, more of the impact of the climate change in agriculture, farmers as who actively work in the agriculture field have to adapt with this challenge and big problem. To help farmers to better climate change policy makers try to understand what's going on in the field and how they perceive and reply to the climate change and adapt with that. So understanding this problem and this situation is a first step to help farmers to different policy and other service that governments and policymakers can provide for the farmers. Based on this, the current research aim to investigation how social capital helps farmers to adapt with climate change. We carry out a cross-sectional survey in southwestern Iran. We use a framework that already have used by other researchers in the domain, in the variety of the fields, like the acceptance of innovations and adaptation with the climate change. These frameworks include different independent variables like social networks, social trust, social norms, social participants, and social solidarity. Based on this research and structural equation modeling, we understand how farmers perceive climate change, how they perceive the risk perception of climate change, and how they adopted with that. Thank you so much for your consideration. I will be happy to answer your question and give your comments. Thank you so much.
So that was our last presentation. I would like to thank you all for participating. Yeah, we would have, I think, 1 minute for questions because we have to leave the room here because the next session is going to start. So if there's a fast or brief question, I would be happy to take it. If not, I would like to thank you and I wish you all the best and bye-bye.